Latvia is a member of European Union, located in the region of Baltic Sea. Neighbors, Estonia, Lithuania, Poland, Sweden, Finland, and Russia. Company working in development and production of precise spectrometric equipment, mainly for nuclear industry, radiation environmental control, and mining industry. We're working for online measurement of concentration of elements in minerals directly on conveyor belt, and we have presentation on Thursday here. And on gamma activation analysis of gold in ore, and that is the subject of my today presentation. We have a booth 227 on this exhibition, and determination of gold concentration necessary on all stages of reprocessing of gold ore. And specialists know that the standard method at present time is a fire assay. Everybody knows that is very precise and sensitive method. And at the same time, it's extremely expensive because it requires special laboratories, highly educated people, a lot of different chemicals, and the produce also chemical waste. Gold gamma activation analysis in future has a great potential if do not substitute this method in future, but not to expand own application in gold analysis. Gamma activation analysis principle is simple. At the beginning, you prepare simply samples, then irradiate these samples with gamma rays, and then read information from sample using precise detectors. Gamma activation analysis provides very high representativity of measurement because weight of probe is about a half kilogram. Short time of measurement provides very high productivity of method, and do not require very careful preparation of samples, and do not produce different waste because it is not destructive method for analysis. This method for gold analysis was developed in former Soviet Union, and first 3 laboratories were opened in Muruntau in 1977, Magadan and Batagay mines as well. After economical collapse, only Muruntau gamma activation laboratory continued to work. In 2015-2016, we fully upgraded system, old system which worked on this mine. We changed linear electron accelerator for a very precise modern model, and change scintillation detectors by high purity germanium detectors with high sensitivity. Approximately at the same time, Australian company Chrysos announced about creation of own version of gamma activation facility for analysis. Muruntau, that is the biggest golden open pit mine in the world, and gamma activation equipment working there still 1977 until now. So that is 48 years experience. All these years we supported this system. They have two complete set systems, and we supported this system until now. As I said, we fully upgraded these two facilities, and using two complete set, in 2-3 years ago, they provided annually 1,600,000 samples measurement, and people who are working with fire assay can compete this productivity of this method. And last year they provided already about 2 million sample measurement. Next year they are planning to install the complete set of gamma activation analysis for their facility. At present time, we produce more modern gamma activation assay complete set. On example of public gold mine, I will show you how looks standard building for such laboratory. You see here. That is gamma activation facility, Aurum Isomer, which we provide for them. You see dimensions 7 meters by 4.5 meters, height about 4 meters with a crane necessary for assembling and disassembling of shielding for electron assay. And you see that on one conveyor you can load your samples, and from another one they are coming from analysis. Inside, construction of this system is very simple. Linear electronic assay. To regret, I don't see that laser is working. No. Linear assay is in shielding, and this shielding, if you want, for example, to replace this laboratory, you can disassemble, remove your laboratory to another place and assemble again. So that is such a removable version. And samples go through transportation system, then they drop to the zone of irradiation where they rotated during irradiation, and they drop to registration system with high purity germanium detectors. We use detectors with registration efficiency 80%. And they lift zone of measurement. You see that all time for separate periods of irradiation, transfer of detector, measurement are very short, and total measurement time is less than 1 minute. It means that 1 minute you receive result of measurement. Again 1 minute, again you have result. Compare with fire assay method. Sorry? Doesn't work sometimes. Oh. Okay, I said about radiation shield. Total weight about 118 tons, necessary to shield radiation of linear array. But the background radiation level is provided very low. No any dangers for personnel. High purity germanium, you see a production facility in our company of such detectors with very big diameter, 110 millimeters of detector, and with excellent energy resolution that provide very precise registration of all elements. As you see, all elements of this system are in one hands of our company. So, I said that not necessity to prepare very carefully ore samples. 3 millimeter is enough. You fulfill such a special container, the diameter you see here on this poster. And as I said, weight of a sample is about ½ kilogram. So representativity is very good. And loaded conveyor for such samples, and every minute, every container goes through measurement of gold concentration. Specialists can see what system measure during such measurement. Everything what you will have in your ore, you will have on the spectra of this sample. You see different elements: yttrium, barium, Gaffney, also lines of aurum, main line 279 kiloelectron volt for calculation of concentration, but sometimes it's possible to use 130 kiloelectron volt for more precise measurements. That is the spectrum of ore with 4.6 gram per ton. Radiation time 10 seconds, measurement time 15 seconds. Next spectrum, that is concentration of gold 3.8 gram per ton, the same regime for measurement, also a lot of different, that is probably from another mine, a lot of different elements you can see here, and software allow to calculate it, first of all, concentration of gold, and additionally for another elements. Another elements also can be calculated, but not necessary to make additional calibration on their energies. Concentration 1.1 gram per ton for this ore element with the same regime of measurement. Again, different elements which contain this sample. And as conclusion, I can tell that for a 15-second measurement, we provide detection limit 0.3 gram per ton, depending on presence of different elements in this spectrum. You understand that all these lines create background, and this background influence for detection limit. But on ultra-low background samples, we provide about 0.2 gram per ton for gold. Precision for such measurement also is very good. For 1 ppm level of gold in the ore, it's about 8%, and 4% for concentration of gold, about 10 ppm. And we provide high productivity of such measurement. more than one sample per second. So it means more than 65 samples per hour. So if somebody needs more detailed information, I invite to come to our booth 227, and I will provide you more information about that. I had only 15 minutes for my presentation, so if you have any questions, please ask. My presentation is over.